In this video, we are learning about the distance formula. After working your way through this lesson in video, you will be able to apply the distance formula to the endpoints of any diagonal line segment appearing in a coordinate or Cartesian grid. Relate the distance formula to the Pythagorean theorem. In a Cartesian grid, to measure a line segment that is either vertical or horizontal is simple enough. You can count the distance either up or down the y-axis or across the x-axis. But what about diagonal lines? This is where the distance formula comes in. You can use the distance formula to calculate any line segment if you know the coordinates of the two endpoints. You will be mentally constructing a right triangle, using the diagonal as if it were a hypotenuse. The distance formula squares the differences between the two x-coordinates and two y-coordinates, then adds those squares, and finally takes their square root to get the total distance along the diagonal line. The expression x2 minus x1 is read as the change in x and y2 minus y1 is the change in y. What this is really doing is calculating the distance horizontally between x values, as if a line segment was forming a side of a right triangle, and then doing that again with the y values, as if a vertical line segment was the second side of a right triangle. That leaves a calculation about the hypotenuse, your given diagonal. The distance formula is a special application of the Pythagorean theorem. All you need to do is plug the coordinates in very carefully. Let's use our line's endpoints 1, 3, and 7, 6, and see what we get. We start by plugging the endpoints into our formula. Then simplify the formula to solve for d. If you did this correctly, you should find that d is approximately equal to 6.7085. You need not even have a coordinate grid in front of you to use the distance formula, so long as you have both sets of coordinate points. So, try this practice problem. -2, 4 and 10, 1. Here are the beginning steps to help you get started. d equals the square root of 10 minus -2 squared plus 1 minus 4 squared. This simplifies down to d equals the square root of 12 squared plus -3 squared. You should really be able to take the last few steps by yourself. Pause the video and see if you can get the right answer. The answer is the square root of 153, which is approximately 12.369. The distance formula gets its precision and perfection from the concept of using the angled line segment as if it were the hypotenuse of a right triangle formed on the grid. You need not construct the other two sides to apply the distance formula, but you can see those two sides and the differences between x values and y values.